Today our topic is composition of functions, and as you can see, two simple objectives today. We're going to learn how to perform compositions. I want you to know what that's all about by the end of this lesson, and then getting further along in this idea of compositions of functions will be the application of this concept. So what I would like for you to do is I want you to think about this little phrase, and it's not going to make a whole lot of sense to you at the beginning, but when you think about composition of functions, we already know the idea of a function, for example, f of x, let's just say f of x is 3x plus 2, and when I want to evaluate a function, let's say for x is negative 2. This is just another way of saying if I input negative 2 into this function, what is the resulting output? Okay, so f of negative 2 would be negative 6 plus 2, which is negative 4. So that's just another way of saying for this particular line, this is a linear function, the point negative 2, remember input and x they're the same. They're referring to the same number, and then output and y, the y coordinate, also the same. So this is where we've been. We know how to evaluate functions for a given number as an input. So here my input was negative 2. The output that resulted was negative 4. And that ends up being one of the points on this linear function. Well, when we talk about compositions of functions, we're dealing with two functions, and it's as though we have a combination. Here's an example of a composition of functions. I have this f function that I need to evaluate, and when I come up with that output, I'm going to turn around and use it as an input in the g function. Okay, so using my same analogy as before, what is g of f of negative 2? Well, I'm going to first of all work from the inside out. I'm going to do the inside first. I'm going to do f of negative 2, and we've already established that that's negative 4. And then that result, that output, really becomes the input that I will use for the g function. So now I'm going to do g of negative 4, and when I input negative 4 into this g function, I get negative 16, which is my final answer. So that's just a quick overview of where we're going. And it leads me to this statement. When you saw this, the way that compositions of functions actually work, how we evaluate them. So this is a statement that I think of when it comes to compositions of functions. The output from the inside, and what I mean by that, the inside function, here it was the f function, the output that resulted from evaluating the inside function becomes the input for the outside. Okay, so it's illustrated here. So I got this output from working inside, and that became the input for this outside function. So the output from the inside becomes the input for the outside. And that's just a little slogan that I use to kind of summarize what will be happening a lot in this assignment. Okay, so with that said, let's do some actual homework examples. Here we're looking at a different way of expressing a composite function. This is the way your book, and some books vary on how they show it. This little symbol here, it's not a 0 and it's not the letter O. This does not say fog. It's the symbol for the composition of these two functions. it could have just as easily been written, and some textbooks will do it this way. They could have shown it like this, meaning we're going to evaluate the g function using an input of 5 first, always work from the inside out, or using this notation, you always start evaluating the function closest to the number. And then once we get that result, that number will become the input for this other function. Okay, so first of all, we need to find out what g of 5 is. And that just means we're going to input 5 into the g function and evaluate. And so what we get, well, 5 cubed is 125 plus 1. So g of 5 is 126. Well, remember, the output from the inside, which is 126, becomes the input for the outside function. So now we're going to turn around and let 126 be the input for this f function. So f of 126 means replace x with 126, that's your input, and simplify. So we can grab a calculator, 3 times 126, that's 378, minus 6. So my final answer here, it's not two different answers, it's just one single answer. This composite function, the answer evaluating this would be 372. Okay, so for letter B, this time I'm going to start with evaluating the f function first using an input of 5. So let's find out what f of 5 is. Okay, so you see how we replaced x with 5, and now we're just going to simplify this. 15 minus 6 is 9. And so now 9 becomes the input for the outside function, which is the g function. So g of 9 is 9 cubed plus 1. So if you need your calculator to find out what 9 cubed is, that's 729 plus 1. So my answer for letter B, again, it's not two different answers, it's just one single answer, and it would be 730. Okay, a couple more of these. Here, I evaluate the h function using an input of -3 first. Well, the h function is a constant. H of anything for x is going to be 9. That includes h of -3. So h of -3 is just 9. It could have been h of 200, and that would still be 9. Okay? Well, I take 9 now, and I use it as the input for the g function, and that's what we had previously. 9 cubed plus 1, we did that just a minute ago, 728 plus, or 729 plus 1, which is 730. Okay, now this one, f of 6. If we input 6 into the f function, we get 18 minus 6, which is 12. Now 12 becomes the input for the h function. Well, it really doesn't matter what the input for the h function is, the output's always going to be the same. And so my answer for letter D is 9. Okay, so that is the type of thing you're going to be doing on 15 through 23. Okay, now let's work on another type of problem. You got 5 of these, just the evens, 24 to 32 even. So what this means is we're going to evaluate the composite f of g, and then we're going to do g of f if they exist. We're going to see where in some cases they do not exist. And then once we've gotten those compositions, if they exist, we're going to state the domain and range for the composed function. Let me show you what this refers to. I'm going to first find the composite f of g. Okay, what this means is, remember, you always start with evaluating the function closest to the number, or in this case, the variable that represents a number. So here is my evaluation. Now, this isn't an equation that we're given or a literal function. We're actually given the inputs and outputs as ordered pairs. So when I evaluate the g function, for example, g of 6, that first ordered pair says if I input 6 in the g function, I get an output of 8. Remember, the x-coordinate corresponds to the input and the y-coordinate is the output. The x-coordinate is also known as the domain. The y is also known as the range. So very simply, g of 6 is equal to 8. Well, composite functions say the output from this inside function becomes the input for the outside function. So now I'm going to evaluate f of 8. And I go up to the f function and I notice there is an input of 8 and it produces an output of 12. So the composed function that results, my original input of 6, gave me an ultimate final output of 12. Okay? So let's keep on going. Let's keep evaluating this g function. G of negative 12. That is negative 5. So now I'm going to go to the f function and use negative 5 as an input, but there are no inputs negative 5 in the f function. In other words, there are no x-coordinates of negative 5. So I'm just going to put an x because this is an example of where it does not exist. Okay? And so I'm just going to keep on going, and I'm going to evaluate g of 0. G of 0, input 0 into this g function, the output is 5. So now that becomes the input, 5, becomes the input for the f function. Well, once again, I don't have any 5 used as any numbers, 5 used as inputs. Okay, there are no x-coordinates that are 5. So this does not exist. So I got one more. I'm going to evaluate the g function. G of 5 is equal to 1. And so now that number 1 becomes the input for the f function. Well, there are no inputs 1. So again, that doesn't exist. So the only result, the composed function, f of g of x, is this ordered pair 6, 12. And so the domain, remember, is the x-coordinate. The domain is 6. And the range would be the y-coordinate, and it's 12. Okay, so that's your final answer to f of g. And so now we're going to turn it around and evaluate the composed function g of f. Okay, so I'm just going to erase this since you have the answer. And maybe over here, I'll just change color. I'll do the g of f composite. All right, so according to the way this is set up, remember I do the evaluate the function closest to the variable or the number first. So now I'm going to evaluate the f function, f of negative 7. If negative 7 is an input in the f function, the output is 0. So that means I use 0 as an input in the g function. And I have an input 0, and it produced an output of 5. So the composed function results in the ordered pair, original input, negative 7, final output of 5. Okay, let's keep on going. F of 4 is equal to 5, input 4, output 5. Now that becomes the input for the g function, g of 5. Well, I do have an input 5 in the g function, and it produced an output of 1. So that ordered pair is original input 4, final output 1. Okay, now let's do the next ordered pair. F of 8 is 12. So now that becomes the input for the g function. Well, I notice in the g function there are no x-coordinates of 12. That does not exist. Okay, so let's keep on going, and we'll do f of negative 3. For an input of -3 in this f function, we get an output of 6. So now let's use 6 as an input for the g function. And there is an input 6 for the g function, and it produces an output of 8. So the original input, -3, to go along with this final output of 8. So the result of the composed function g of f of x gives us these 3 ordered pairs. Okay, so this represents in the composed function. So now let's just do I'll label this as domain. So remember, domain means the x coordinates, -7, 4, -3, and range will be the y coordinates, 5, 1, and 8. All right, so you're really getting 2 different answers for these problems 24 to 32 even. So let's try another one. All right, so let's do this f of g of x first. This composite. So we're going to evaluate the g function first, starting with this ordered pair. G of 5 gives me an output of -4. So when I do an input -4 into the f function, there is no -4 x coordinate, so this doesn't exist. So let's go to the next ordered pair. G of 4 gives me an output of -3. Now let's input -3, and that doesn't exist in the f function. All right, so g of -1 gives me an output of 2. So now 2 becomes the input for the f function, and there is an input of 2 in the f function, and it gives an output of -2. So that results, the composed function results in this ordered pair. Original input, -1, final output, -2. And then finally, we've done the first 3. Now g of 2 is equal to 3. So what is f of 3? Well, there is no input 3 in the f function, so it doesn't exist. So f of g of x is the composed function, is just that one ordered pair, and so the domain is -1, and the range is -2. All right, so let's jump over here, and we'll do the other composition, g of f of x. Okay, so again, start inside, work your way out. So let's evaluate the f function. F of -1 is 11. So there is no x-coordinate 11. There is no input 11, so that doesn't exist. F of 2 is -2. And when I try to do g of -2, there is no x-coordinate -2. There is no input for that. So let's do f of 5, that's -7. So when I use -7 as an input in the g, that doesn't exist. And then finally, f of 4 is -4. So what is g of -4? There is no -4 x-coordinate or input in the g function, so that doesn't exist. So the bottom line is this composition doesn't exist. And so the domain is just the empty set, and same for the range. Okay, that takes care of our example B, and we'll just run through one more. Start with f of g of x again. So let's evaluate first the g function. G of -1 is 5, so what's f of 5? Doesn't exist. G of -2 is 6. So what's f of 6? F of 6 is 3. So that gives us the ordered pair -2, 3. Okay, G of -3 is -1. Is there an f of -1? Doesn't look like it, doesn't exist. So finally, g of -4 is 8. So what is f of 8? f of 8 is -1. So we get the ordered pair -4, -1. So these ordered pairs represent the composed function. So we'll list the domain and range. The domain is -2, -4. And the range is 3, -1. All right, so let's go the other way. Let's do the composition, changing colors, g of f of x. Okay, start evaluating the f function. F of 12 is -3, so g of -3 is -1. So that's 12, original input, -1. Okay, f of 9 is -2. So now let's do g of -2, and that's 6. So that gives me 9, 6. All right, let's keep on going. F of 8 is -1. So g of -1 is 5. So that gives us 8, 5. And then finally, the f of 6 value is 3. So g of 3, see, g of 3 doesn't exist. So these ordered pairs represent the composed function. And so we can list out the domain, the x-coordinates, 12, 9, and 8. And the range, the y-coordinates, -1, 6, 5. And that is it. That is the problems for 24 to 32 even. And then that brings us to this last part, this last set of problems, where we're still doing composite functions, but this time instead of inputting actual numbers in for x, we're going to be inputting actual functions. Okay, let me show you what I mean by that. Let's start with f of g of x. Remember, we take the inside first, and we don't have a number actually to evaluate here for x. So what we're going to do is we're going to take this entire g function. Okay, what this says to do is to take the g function and put it in for x in the f function. Okay, think of replacing x with x plus 5. And when you do that, you're going to do 2 times x plus 5. And when you simplify, you get 2x plus 10. So f of g of x is equal to 2x plus 10. Going the other way, now we're taking the f function. Let me erase my green line here. Now I'm taking the f function and I'm going to put it in place of x in the g function. So it's pretty simple. We're going to let 2x replace the x in the g function, and there is nothing we can do to simplify this. So g of f of x would be 2x plus 5. Okay, so the domain and range for each. Well, these are both linear. So the domain is going to be all real numbers whenever you're dealing with, well, the domain is going to be all real numbers for all of these. We can use any domain we want. And for lines, the range is also going to be all real numbers. Because remember, these are just lines that they start at 10 on the y-axis and they have a slope of 2, so it's really 2 different lines that extend forever and ever. And so for linear compositions like these, x to the first power, the domain and the range will always be all real numbers. Okay, well, let's try this one. Same instructions. Let's do the f of g of x. And that means we're going to take the g function, its closest. Okay, you notice how the g is closer to x, or if there's a number there, we would evaluate this first, and then that would become the input. So what this says to do is to take the g function, this 4x plus 3, and we're going to put it into we're going to input it basically into this f function in place of both of these x's. Okay, so here's what that looks like. When I input 4x plus 3 in for x, I get 2 4x plus 3 squared minus 4x plus 3 and then plus 1. And now I just work on simplifying. So remember, before I multiply, I have to do the exponent. So when I square 4x plus 3, I get 16x squared plus 24x plus 9. I'm going to go ahead and do this subtraction because remember, I'm subtracting both of these. That's minus 4x minus 3, and then I'll bring down the plus 1. Distributive property here with 2, 32x squared plus 48x plus 18 minus 4x minus 3 plus 1. And now let's combine like terms. 32x squared plus 44x, 48 minus 4. And then we have 18 minus 3, which is 15, plus 1, which is 16. So f of g of x is equal to this. Now this is not a line. The domain is still going to be all real numbers for quadratics. The domain is going to be all real numbers for all of these. But the range, that's a different story. Remember, this is a parabola. And it's a parabola that opens up. Okay? Well, where's the vertex? In order to know what the range is, we're going to have to know what the vertex is. And how do we find the vertex? Well, we have two different ways, but probably the easiest is to go back to our old trusty formula, the opposite of b over 2a. So let's go ahead and use our calculator. The opposite of b, which is 44, over 2 times a. Okay? So let's see, in our calculator, 44 divided by 64, that's 0.6875, but this makes it the opposite of that, so negative 0.6875. Okay, so finding the vertex, what we've found so far is the x-coordinate. Write that a little neater. You find the AOS, you found the x-coordinate of the vertex. Well, it's the y that we really need to identify the range. So how do we find the y-coordinate? Well, in case you forgot, we plug this in. We take negative 0.6875 and we plug it in for both of these x's. All right, so you might want to just use your calculator at this point, and you're going to do 32 and then parentheses negative 0.6875 close parentheses squared plus 44 times, I got parentheses, negative 0.6875 close parentheses, and then plus 16. So I get 0.875 as my y-coordinate. So in other words, if this were a parabola, I'll just do a little rough sketch. This is a parabola that opens up. Let's just say that this is negative 0.6, just slightly to the left, and this is negative 0.6 and then positive 0.8. We'll just rough sketch it. And here's a parabola that opens from here. Well, the range is all the numbers that are greater than this y-coordinate. Remember, y, the range is corresponding to the y-axis. So we could say the range is all y such that y is greater than or equal to, because we would include the vertex, 0.875. So for the range for these quadratics, you're going to have a little bit more work to do to come up with your answer. Okay, so before we go on, let me just make sure you understand what the answer is. Our composite f of g of x, I'll circle, that's right here, domain, all real numbers, and then this is the range. That's the complete answer. But you're going to need that opposite of b over 2a, find that number, and then plug it back in to get the y coordinate of the vertex so that you can determine what the range is. Okay, I need more space, so I'm just going to erase this, and then we'll work on the g of f of x. So we got half of our answer. Now let's get the other part. Okay, so for the composite g of f of x, now we're going to take the f function, and we're going to use that as an input, this whole function as an input into the g function. Okay, so it's going to look like this. G of f of x will be 4 times, and in place of x, I'm putting this whole f function, 2x squared minus x plus 1 plus 3. And now we simplify. 8x squared minus 4x plus 4, bring down plus 3. And then finally, 8x squared minus 4x plus 7. That is our g of f of x composite. Okay, so domain, that's going to be the same, all real numbers for parabolas. But we talked earlier about how the range is going to be a little different. We've got to find out where the vertex of this parabola is so that we can know what the range is. Okay, so once again, I'm going to use the opposite of b over 2a. 2 times 8 is 16. 16. How about that? Okay, so it's the opposite of negative 1/4, which is positive 1/4. Or if you want to plug into your calculator, you could say 0.25. So we know what the x-coordinate of the vertex is. Now, how do we find the y? We're going to put 0.25 in for both of these x's. 8 times 0.25 squared minus 4 times 0.25 plus 7. So let's grab our calculator. And 8 parentheses 0.25 close parentheses squared minus 4 parentheses 0.25 close parentheses plus 7. And that is 6.5. All right, so once again, if you need a picture, this will be a parabola that opens up because the a number is positive. A fourth, 6.5. I'm just going to guesstimate. That's about right there. So it opens up from here. All right, so again, the range is corresponding y coordinates that would continue on forever along this parabola. And they would start at 6.5, and they would go up forever from there. So we would say the range y such that y is greater than or equal to 6.5. So to finalize our answer here, this is the composite, and this is the domain and range. Okay, I hope that helps. This is the type of stuff you're going to be doing on your homework assignment. And if I can help you in any way, send me an email or come see me in academic support.